The company collaborated with key defense bodies, including the Indian Navy and BHAL, creating path-breaking drones for surveillance, rescue, and anti-drone defense. Beyond defense, his drone have supported life-saving operations with the Goa government, large-scale surveillance with Indore police, and even environment regeneration through drone-based seed tree seeding. The advances mark growth and progress in India's defense capabilities. Recognized nationally for his contribution, Mr. Mishra is not only a technologist but also a leader, a TEDx speaker, and a mentor for young innovators. He has served as a judge in hackathons held at NIT Jaipur and at Indore Management Association. He was honored as chief guest at the National Conference on Startups, Patents and Copyrights, organized by the Institution of Engineers of India. Please join me in giving a warm welcome to Sir. I would like to request Sir for the technical session. Sir, please.
Thank you so much, ma'am, for the quick introduction, and very good evening to all of you. Uh, Let me start sharing my screen. Is my screen visible to all of you?
Yes, sir. Yes, it's visible.
Yeah. Okay. So, very good evening to all of you. In today's session, we'll mainly talk about the components of IoT. Uh, Basically, we hear a lot about IoT, but today we'll go a bit depth. Like what are the three pillars of IoT? That is sensor, actuators, and communication protocol. We'll go into deep dive in each of them, and we'll see how we can like use them, or like how they are already being used at multiple places, and what are the future opportunity we can create using these sensors, actuators, and communication protocol. So before this, uh, I'm assuming like audience is having a bit of idea about the IoT. Okay, so see, we are everyone like everywhere we hear a lot of this technical jargon like IoT is there, AI is there. Okay, so IoT, what is the Internet of Things? Okay, so it's nothing but it's a network of physical objects embedded with technology to connect and exchange data over the internet. So what we do in IoT, basically, we have multiple small components who are connected with internet. They are doing their task and sending the data back to the cloud. And based on some interpretation, it's taking some action. Okay. So if I talk about IoT, I can easily see like it's connecting the physical world to the digital world. Okay. Then we have smart devices that can sense, think, and act. And the most important thing is it's a massive growing network of things. Okay. So network is very important here. That's why we are talking about the three pillars today. So as I was speaking earlier, the IoT ecosystem functions as a centralized network. All connected devices send data to a central cloud for processing and analysis, and then the central cloud sends back the command to the control the device. Okay, so as you can see in this image, like there are multiple devices who are doing some ad hoc thing or collecting data at the individual level. Then it's sending those data to the centralized cloud server. The server or the centralized cloud will do some manipulation, interpretation of the data, and the decision making will take place at this level, and then it will relay back some of the command to these devices, and based on those commands the devices will take some action. Real life example of IoT is like see, now we have smart air conditioner, a temperature sensor which automatically sends the temperature, and then it's when it sees like the temperature and it's sending back the temperature data to the cloud. When it sees okay the temperature is more than this degree, it automatically reduces the temperature or cools down the room, and there are many other use cases. Needless to say, IoT is very important because it's a fundamental shift in how we interact with technology and our environment. Before IoT, there were standalone devices who were doing the thing standalone, but there was no connectivity. With the invention of internet, it became very important for us. It became very important for all of us to connect the sensors to a central command, and then that command, and then that central command will do some level of computation and send back the data. Okay, so these are the main pillars where IoT is helping us. First is automation. See, now we are automating a lot of the manual process just to save the time and labor. Okay. Then efficiency. Efficiency is very important because it is helping us to optimizing resource use like energy in smart grids or water in the agriculture. Okay. Earlier, we need to manually monitor. Now, with the help of IoT device, we can monitor remotely and also autonomously. Then data-driven decision. There are many places where we need some historic data or data over a period of time. With the help of IoT devices, we are getting that data and storing that. And that is giving us a common trend. Based on that, we can further fine tune the sensors or make smarter decisions. Then, needless to say, with the help of IoT, now new innovative business model and consumer segment is also opening up, because since now we have sensors with whom we can interact remotely and we can control them remotely. So and kind of new market is also opening up. So there are the three main core component of IoT. Okay. So first is like sensors. Sensors are like eye and ear of the system because they are the thing which collect the data for us. It can be a temperature sensor, it can be humidity sensor, or it can be any other sensor. If I talk about human body, we can like say sensor are like our eye and ear. Okay. Then actuators. Actuators we can call them as hand and the feet, which enable us to take some action. Okay. And communication protocol, the language these IoT system understand, because in order to communicate with the devices and sensor, we need certain kind of language. Like today we are speaking in English, we can speak in some other language also, which everyone understand. For machine also, we need some sort of communication protocols. So these are the three main component of IoT. Any questions till now? I will take a pause here. I'm assuming no, and I will move ahead.
No, sir.
Okay. So now let's come to the sensors. 1 second. So what are the sensors? So like all of us know what are sensor. A sensor is a device that detects and measures a physical property or a phenomenon and records, and then sometimes it indicates also, and sometimes it respond also. So they are the initial data collected in any IoT system, translating the physical world into digital data. Let me tell about, like, say sometime there is like storm kind of situation. Then there are some airspeed sensor which can measure the airspeed and will collect the data and tell us, okay, based on that airspeed we can detect, okay, it's very high, it can be a stormy weather or something like that. Okay. So the main purpose of sensor is to convert the physical input into a measurable electrical signal. Okay, which further and the IoT, the further other component of IoT understand and take some action. Okay, and they are function. They are the first link in the IoT data chain. Okay, analogy: if IoT is the body, sensor are the sensory organs like eye, ears, and skin. Because using them only we can sense the environment. The way we sense the environment using our skin, eyes, ears. Similarly, any IoT network, they are the external thing which help us to gather the data. So it's a very simple workflow diagram. Okay, so the like how the sensor works. So it gets some physical input. Okay, like the temperature, light, or pressure. Then the sensor, for these there are multiple sensors. Like for temperature we have thermistor, for light we have photodiode, and the pressure we have strain gauge or some other kind of sensor. What the sensor does, it converts the analog to digital. Basically, there is some analog to digital converter, ADC, and then it will convert that signal, and finally it will create the digital data, which any microcontroller can use. Okay, so there are few common microcontroller which we use in day-to-day use. Like one of them is Arduino. Arduino is very popular. All of you must be using it. Then there are few more like ESP32 is there. Okay, and then there are few more like we can use. Any doubt here? So for any microcontroller, we need the ADC data. Okay, so this ADC data is very important, and the sensor converts the physical input to ADC data, which any microcontroller can understand. Then these are the common categories of the sensor based on what they are designed to detect. Like mechanical sensors, what they do, they measure the physical stress or the movement. Example, accelerometer in a smartphone. Okay, so we all use the smartphone. Okay? So accelerometer basically detects the motion and orientation. Based on that, we take some action. And this accelerometer is also very much used in the drone also. It helps us to measure the velocity of the drone. Okay. Then there are thermal sensor to measure temperature or heat, like thermistor in a smart thermostat. Like in foreign country, even in some advanced home in the India, like we have thermostat where we can like fix the temperature. Okay. So how does that work? It takes the input from the thermal sensor. Based on that, it's basically either increases the cold or decreases the cold. Okay. Then there are proximity sensor detect the presence of object without being contact. So most of us are using it, correct? Hand sanitizer is one thing, okay, like infrared based hand sanitizer. Or now these days we see like there are many taps where when we take our hand in front of tap, it disperses the water. So these are being used by with the proximity sensors. Okay. Then optical sensor, like these sensors are very important to detect light, color, or any other optical property. Like a camera sensor in a security system, it can detect even when there is dark, like thermal. There are thermal sensor, thermal camera sensor, which works even in the night. And then there are IR infrared sensors also. Chemical sensors are also one category which detect the presence of specific chemical or gases, like carbon monoxide detector is there in a smart home. And then there are a few other small sensors also which can detect LPG or any those kind of gas leakages. So these sensors like sense the environment when there is some leak, it detects. Basically, it converts them to ADC data and then pass on this to the microcontroller. Acoustic sensor, they detect sound or vibrations, like microphone sensor in a voice activated assistant. Like these days, most of the phone you say, like whether it's iPhone or Android. If it is iPhone, we say, "Hey Siri," then it's automatically get activated. Correct? Similarly, in you must be heard about Amazon Smart Home. Like you say Alexa, then it detects your voice and respond to your command. So that is being done using the acoustic sensor. These are some example like smart agriculture, where what we are doing, we are using soil moisture sensor in the fields to automate the irrigation. Okay, so basically it will measure the moisture, and based on that, it will like we
Uh,
can yeah
Excuse me, sir. There is a question.
yeah
Which sensor is used for irrigation system? I
yes sir,
think
please go ahead. And
which sensor is used for irrigation system? I think irrigation होना चाहिए.
I think it should be
Yeah,
irrigation.
it's irrigation.
Yeah.
Irrigation.
Yeah. So there are multiple sensors. Like one is the the soil moisture sensor, which we use, which detect the moisture in the field. These days, sir, we are also using a couple of sensors where we are measuring thermal sensor is one. Sorry, camera sensor is also we are using, where with the help of camera sensor we are capturing the images, and then we are applying some AI, and based on that we are spraying the fertilizers in the field also. So that is another sensor. This soil moisture sensor is there. So these two I'm aware of, like which I have practically used. And then there are many other sensors also which can be used. Then, sir, in healthcare, like we have multiple sensors. These are the common like blood pressure and glucose monitor. Like they are being actively used. During COVID, sir, I am sure like most of us have been used the SpO2 sensor, correct, which used to detect the SpO2. Again, that is being driven by some sensors, which so it was basically combination of couple of sensors, which were there was some IR sensors which were uh, which were passing through our finger, and then we were detecting the red light wavelength. Based on the wavelength, we were detecting how much oxygen it is carrying. So that way it works. So healthcare also there are a lot of sensors which are being used. ECG, like it's one of them, which I think many older patients use. In industrial automation, sir, there are many sensors like vibration sensor is there, the temperature sensor is there, gas leakage sensor is there. Okay, and the smart cities, air quality measurement is also there, where we put on sensors and detect the air quality. I feel pride to say in Indore also we are doing some experiment with air sensors in our drone. So we are flying our drone in some crowded area and detecting the air quality. So that trial also we are doing. So you see, like sensor is like we can use sensor many places, and they are the backbone of any IoT systems. Now this is very important slide, uh, where basically now I have a problem. Say I am designing a solution for a particular problem statement. I need to choose a very right sensor. Okay. So these are the few points which I could write based on my experience. The first is accuracy and precision. Uh, so whenever we are trying to solve any problem, we are choosing a sensor. We need to make sure it should be pretty much accurate. Because if we are not getting the correct value, then the further things, further decision which are based on this sensors data uh, will not be that accurate or will not yield the result which we wanted. Okay. Then the range is like how sometimes it's important, like what is the minimum and maximum value it can detect. Okay, so say I'm talking about a temperature sensor, then so I need to understand what is the minimum operating temperature where it can operate. So I say if I'm deploying it in areas where the temperature drops to minus 15 or minus 20 degrees centigrade, some application I'm designing, will my sensor work there? Or if I deploying it some area, some say some industries where the temperature goes very high, you know, say 100 degree, 200 degrees centigrade or more than that, so will my sensor work there? So based on the use case, I need to figure out the range also. Third and the most important thing is cost and power consumption. Cost is, all of us know, it's very important from the commercial angle, because whenever we are driving a solution, it should be profitable also. And then power consumption. Uh, Power consumption is also very important because we need to make sure like our sensor or our IoT network should always keep on running. Okay, so from where my sensor will get the power, how easy it is to provide the power. These are the questions which we should keep in the mind while designing a solution using the sensors. Suppose it's taking 5 volt, then it's very easy. I can provide any standard battery. Or say if I'm deploying it in jungle or some other area, does the solar works? So I have a battery. Say, and does it auto charge itself? Those kind of power thing also comes into the mind when we are designing the solution. Then environmental factor, will it work in extreme temperature or humidity? Okay, this is also very real world scenario, because if I talk about India, it's a very versatile geography also. Correct? You are developing a solution, say for the western borders, that is the Jaisalmer and all those things. The scenario is totally different. There are extreme temperatures. If I go to the northeastern section, northeastern part, the temperature, the scenario is totally different. Temperature will not be that much, but there will be lot of humidity. So I need to take care of the environmental factor also when I am designing some solution using the sensors. So while selecting the sensor, I need to first analyze in which geography I am designing, and these are the things which I think is very important for all of us to consider while designing any solution using the sensors. Okay. So here, like I would like to take a pause. Couple of questions for you to just introspect, whenever you get some free time. So the very first question is like we always need to make sure like what is the primary function of a sensor in an IoT system. When I am talking about IoT system, I need to understand what is the primary role or function of a sensor. And then one question, like if you get some free time, try it your free time. Say if you are building a system to monitor fish tank, what kind of sensor will you need? So this opens a opportunity window to like think and further think and uh, derive some solutions. Okay. So so far we have covered the first part of the session, that is sensors. I'm assuming like I was able to like justify the topic and able to explain you what are the sensors and how we can select the sensors, what are the different kind of sensors, and what are the their use. Now coming to the second important part, which is actuators. We can also call them hand and feet of the IoT. So if the sensor are the input, actuators are the output. Okay. So actuator is a component that takes an energy source like electrical signal and converts them into physical action or motion, such as turning a motor, opening a valve, or moving a robotic arm. Okay. Because with with sensor we cannot do anything, but we need a combination of sensor, actuator, and communication protocol. So sensor is giving us the data, then actuator is taking that input and giving us a particular output. Okay. So what are the purpose of actuator? To perform a physical action which is visible to us. Okay. The function is like they close the loop by acting on the data insights. Okay. If I talk about human body analogy, we can compare actuator with the muscles, like sensors, eye and all. They are giving us the data, and muscles are the thing which are doing the actual work. Okay, so sensors are giving the data to brain, and then our muscles, based on the brain input, our muscles are taking the actions. So now, how does an actuator works? Okay, so the process of the actuator is the inverse of a sensor. It receives a digital command and uses a driver to convert that command into physical movement. Okay, so from sensor I'm getting some digital signal. Then we have some driver circuit. Okay, then we have an actuator, that is motor, solenoid, or valve, and then we will do some physical action. In subsequent slide, we'll see how actuator works. So these are the category of actuators. Like we were having the category of sensor. Similarly, we can also classify actuator based on the type of the motion or force they generate. First is electrical actuators. They uses electricity to generate motion. Example, a simple DC motor in a robot wheel. Okay. So suppose I'm designing a robot. Okay. So a normal DC motor can be called as an actuator. If I talk about the drone, the the motor of the drone, okay, they can also be considered as an actuators. Okay. Then there are they will also be an electrical actuator, and they are also using the DC currents. Okay. Then there are hydraulic actuators. They use fluid pressure to generate force. Okay. Like electrical actuators, we are using electricity to generate some motion or something like that. Hydraulic uses fluid pressure. Example, a heavy duty piston in industrial machinery. Then there are pneumatic actuators. They use compressed air to create motion. Example is robotic gripper on a factory uh, uh, of assembly line. Okay. So these are the three way like which an actuator works. One is electrical, second is hydraulic, and third is pneumatic actuators. Okay. Apart from these three popular, there are other more actuators for other tasks. Solenoid. So solenoid, we most of us have studied during the college, correct? So they use an electromagnet to create a linear motion. Example is a smart locking mechanism. Servo motors, they offer precise control over angular position. So, like servo motors are heavily used in controlling robotic arms, pan, and tail. Let me give another real world example where servo motor we are heavily using the gimbal. So, most of us were using camera, correct? So, so you see like gimbal, what the gimbal does, it helps the camera. It helps the camera to capture a feed with any without any vibration. So gimbal makes sure the vibration goes to the zero. Suppose you are say in a drone, when you're flying a drone, there is a lot of vibration due to the motors and all. But if we do not use the gimbal, the camera feed will not be usable. There will be a lot of vibration, something like that. But with the help of gimbal, we get a like smooth camera feed. So servo motors are used in the gimbals also. Servo motors can also be used to perform specific tasks. Suppose you want to open some, since I belong to a drone company, I will give a real world example where we are using servo. Like we are heavily using servo motors in dropping grenades. So we are supplying some drones to the defense, where if you want to drop some grenade, we are using the servo motors to perform that action. When we do some command, servo motors rotate some particular angle, and based on that, we pull the pin or we drop the grenade. Then relay switch, like relay switch uses electromagnet to open or close for another circuit, like smart switches that turns on the fan on or off. So these days there are many fans which are very smart and controlled by the remote control. There we are using the relay switch. They uses an electromagnet to open or close any other circuit. So this is like say I try to create a scenario where say there is a sensor which is sensing the temperature. Okay, then it basically result is like if the temperature is greater than 24 degrees centigrade, it's sending the data to cloud. The cloud will pass on the information to actuator, and actuator what the actuator will do, it will turn on the AC. So there is a temperature sensor which is collecting the temperature and sending it to the cloud. Now, when the cloud gets this data, it will process it will have some logic. Like in this case, I have written one logic. If the temperature is greater than 24 degrees, turn on the AC. The sensor gave me the signal as 25 degrees centigrade. See, till here, the system will not work because there is no actuator. Now, once the sensor did its job perfectly, it sends the temperature and send it back to the cloud. Now, cloud also did its job. It has some logic. Now the cloud will pass on this command to actuator, which will actually turn on the AC using some relay switch or some any other mechanism. Correct? So we can use the relay switch here also to turn on the AC. This way, a sensor actuator loop works in a smart home. I hope I am able to make you understand the sensor and actuator workflow. Okay. So far we have talking about the sensor and actuator. Okay. I will again take a pause here and will be waiting for your questions if any. So just to check our understanding of so far, say one small question: if a smart irrigation system that needs to open a wall to water on land, what type of actuator we can use? I think we have discussed the actuator which works with the water. So I would request you to like think in your free time and design a solution for this. And then a very basic question, which I think you might have understood now until now. What is the key difference between a sensor and an actuator? So you can like say like sensor is like eye, ear, or skin, and actuator is like muscle, which does the real world thing. Any questions? I will take a pause. Otherwise, I will move to the next slide. Okay. I will go to the other part. Now, the another important pillar is communication protocol, the language of IoT. So far, we have been dealing the hardware part of it, okay, whether it's sensor or actuator. Now, the communication protocol is very crucial because without it, nothing will work. Sensor or actuator are useless without a way to communicate. Sensor is showing some temperature, but what will we do with that temperature? We need to find a communication protocol which we can use to communicate that to the cloud and then from cloud to the actuator. Communication protocol are the set of the rules that govern how data is formatted, sent, and received between the devices. They are the language that enables interoperability. Okay, so they are very crucial for any IoT system to work. These are the key points which we can discuss here. One is interoperability. Interoperability. It allows different devices from different manufacturers to work together. So, in order to do that, we follow a common kind of uh, standard which any device manufacturer will follow. Because you can get a temperature sensor from multiple manufacturers, but all of them will work in a certain way. It will give you the output. Remember, we will discuss like we need some data in ADC format, which any controller can understand. So this interoperability becomes very important. Even if I open some company and say start manufacturing temperature sensor, I need to adhere to the industry standard and industry spec. Data integration, integrity. Whenever we are using any communication protocol, we need to make sure data is not corrupted during the transmission because sometimes it may lead to the disastrous effect. Say if I am showing temperature, say if I'm using temperature sensor or if I'm using some camera to detect some movement, and if I'm getting the wrong or corrupted data from the camera sensor, and based on that I'm triggering some specific or some critical say mission, then this can jeopardize that effort. Okay, efficiency. Definitely, needless to say, any communication protocol has to be efficient because it consumes the bandwidth and there is some power consumption with it. It has to be optimized. Otherwise, we'll end up wasting the resources. Then there are network versus application protocol. We can broadly divide IoT protocol into two layers. One is the network layer, and second is the application layer. Okay. So network layer protocols are like they are handle the physical connection between the devices and the network. They are about how data gets from A to B. Example: Wi-Fi, Bluetooth, or LoRaWAN. Okay. So say suppose two devices want to communicate with each other, they need to use some network protocol. Let me give a real world example. Say two Raspberry Pi devices wanted to communicate some information through each other. They can either use SCP or some any other kind of, or you can host one web server over one Raspberry Pi and second Raspberry Pi is accessing that. Okay. So how they will communicate with each other? They need some medium. So Wi-Fi is one of the medium. Bluetooth is another medium. And third thing is LoRaWAN. LoRaWAN gives us the advantage of LoRaWAN is it gives us a much higher range, close to 8 kilometers. We can communicate with each other. Okay. In the subsequent slide, we'll further see that. Uh, then there are application protocols. They handle the data. These are network protocols. Make sure like they are kind of bridge to pass on the data. Okay, from one device to another device. Application protocol handle the data exchange and format. They're about what is being said. Example: there are few application protocol like MQTT, COAP, and HTTP. I personally use HTTP a lot. Okay. Then common network protocols. I will see when these are the common network protocol. One is the Wi-Fi. Okay, like all of us are aware with the Wi-Fi. The pro Wi-Fi is like they have high data rates and wide adoption. Needless to say, like almost uh, most of the houses in any smart cities are using the Wi-Fi. Okay, what are the cons with it? Higher power consumption. Second, the limited range. I cannot expect a range of more than 200 meters from a Wi-Fi. It will be even lesser than that. Then there is another kind of network protocol, which is Bluetooth or BLE. Like most of us are using it in our mobile phone. These days, cars also support the Bluetooth protocol. So the pro is like they consume very less power and they are very great for short range communication. The cons is like they have very limited range and lower data rate. So with limited range, it's fine. But lower data rate means I cannot transmit high definition video or some other data which consumes a lot of bandwidth using the Bluetooth. Okay. Then for a wider area or specialized application, other protocols like cellular, we are using 4G and 5G. They have a wide coverage, high data rate. The cons is like they require high power and the subscription cost. And if you are a manufacturer, it will further involve very high cost, one-time setup cost. Okay. LoRaWAN, they provide a very long range, up to 15 kilometers, and they consume very low power. Okay. Uh, Okay, so they are very popular when we want to pass some data in any let me give a real world scenario which we are using. So like in Goa, what we are doing now we are flying our drones to detect if a person is being drawn or not, and if detect some person is being drawn, we immediately pass that information from drone to base station, and then base station takes some action. It either sends some ferry to rescue that person or it sent another drone with life-saving jacket. So under those kind of scenario, when there is no when you need a good range, say 1 kilometer or 2 kilometer, LoRaWAN is extremely useful. Even in the jungles or hilly area, you get a very good coverage with the LoRaWAN. If you are in the line of sight, you usually get 7 to 8 kilometers. The cons again, they have low data rate and they are not suitable for real-time application. So what happens with the LoRaWAN? You can use it to trigger any alarm or some those kind of scenario, but you cannot, since it's again it is having a very low data rate. I cannot transmit images or video using the LoRaWAN. All I can provide the control data to say some GPS of a location, some alarm, some trigger. Those we can pass using the LoRaWAN. Then there are some protocols that define how devices talk to each other and the cloud. MQTT is like messaging, queuing, telemetry, and transport. Okay, this is one protocol. The pro is it's lightweight, simple. It's a publisher subscriber model and perfect for resource constrained devices where the resources are limited. The main cons with it, there is no built-in security. So we need to add and add an extra built-in security kind of encryption or something like that with the MQTT. Then COAP protocol, they are also designed for low power devices similar to HTTP, but they are more efficient uh, and they are less mature than MQTT. HTTP REST, like as I said, like they are universal and very well understood. Most of the devices are using HTTP REST based. Cons is like there is some high overhead. High overhead means the packet which carries HTTP packet at the application layer. It has apart from the data part, there are many headers and all those things, and they are not ideal for tiny devices or small sensors. Okay, so which every common network protocol we get some pro and cons based on our scenario. We need to choose the network protocol. Okay, the way we were selecting the sensor, the way we were selecting the actuator. Similarly, for the protocol selection also, there is some criteria. So while you are designing some solution, you need to make sure what suits your need actually, and what is the system performance, and what is the cost associated with it. So these are the things which I could like figure out for you. One is range. So say if the range is very short, you can go with the Bluetooth. And if you really need a long range, like in few kilometers, go with the LoRa band. Okay. Then power consumption, you need to again make sure like but whether it work on the battery powered or always on devices. Okay. Data rate. This is again very important. As I said, like how much data needs to be sent per second. If you really want to send some images or video, you cannot go with the LoRa band. You have to use something else. Okay. If you just want to send the control signal or something like that, you can use that. And then security. How critical is the data and how secure must the connection be? Sometimes you need to share sensitive data. During that time, you need to be very careful with the protocol which you are using, because you cannot transmit any sensitive data over a long distance. There can be like man in the middle or some other who might be listening to the same frequency band or something like that, and easily they can get your data whatever you are passing. So that security is very important. Scalability. How many devices will be on the network? How my communication protocol is work? Does my communication protocol supports multiple devices at once? Those kind of things we need to make sure while designing the uh, while selecting the protocol. Okay, so I think we have pretty much covered everything. We'll quickly recap you. So we'll started with what is IoT. We went to what is sensors. We talk about the most common sensors, like what are they and how we can use them. Then we went to the actuators. We saw how actuators works. What are the different kind of actuators? Electrical, mechanical, uh, acoustical, and then how does they work? And post actuator, now we came to the communication protocol, because that is what it enables device to interact with all. We saw the most common communication protocol which are widely used in most of the IoT devices, and then we discussed about, like, say I need to select some protocol. So what I need to select based on my use cases. This is the final slide where I try to put everything together. So, say this is a scenario where a sensor like weight sensor on a self detect when the milk carton is empty or not, or a temperature sensor which monitors the internal temperature. Okay, it will do some communication to the cloud. Now, this can communicate either using Wi-Fi protocol. Uh, so you have a fridge, okay. So you want to design a smart fridge, so you can put this sensor there. Then they will communicate with the cloud. And using MQTT, you send the weight and temperature data to the cloud. Okay. Then, but the cloud does some computation. Actuator, what it does, it display on the face screen, alerts the user. Okay, something is, uh, say you need to like fill your milk carton is about to get empty. Go and fill it. So this kind of logic is putting this kind of logic is being done on the cloud, and then cloud is instructing the actuator to take some action. Actuator can also order automatically with the nearby grocery store if it is allowed to do that, or it can turn on LED indicator to turn the light on. So this is a real world example of a smart fridge with all three components. I hope if you understand this, like I think you can understand all three topics very easily. I will take a pause here, and now I'm open for your question or feedback. Okay. So we'll go to the challenges and the future trends basically. So Definitely, with any technology, we face some challenges, and our technology has a huge feature ahead. The same holds true with the IoT also. So while IoT is incredibly powerful, it is not without its challenges, because it also has its challenges. However, the future promises even more sophisticated and integrated system. So what are the challenges? Like, first challenge is like security and privacy. Okay, securing a vast number of devices is a major challenge, both hardware-wise, then technology-wise. Okay, then interoperability, because ensuring like devices from different vendors can communicate, it's again a big challenge. When you're designing a solution, you need to make sure like, okay, this is my sensor, these are my sensors. I need to make sure like they can coordinate or communicate with each other. This is also a challenge. Data overload, managing and analyzing the sheer volume of data which is being generated. We also need to make sure like the sensors or all those things, they should be accurate. The data rate should be low. The data and data should be easy to understand, or in such a format like it support our communication protocol also. Our cloud should be able to make some decisions. uh, but what are the future trends? I see future a lot of. I see. I'm very excited about the future, because now we have a lot of things which is helping us, like edge computing, like they're processing data locally on the device to reduce the latency. You might have heard a lot about edge computing. So these are like they are small computer with small microcomputer, I would say, with built-in sensor capability, and they process the data locally on the device. And one example I can give you, real world example, is ESP32 cam. So ESP32 is a microcontroller, and it has embedded camera. So on real time, it can take the feed from the camera and do some say judgment based on the images, like detect human face or something like that. So they are helping us to take real time decision and reducing the latency also, because there is definitely latency when you pass on the data to the cloud, and then from cloud back to the actuators or some other sensors. Then AI and machine learning, yeah, like as we all know, like it's a booming field, and they are also making our days smarter and more autonomous. So with the help of AI models, we mean earlier what we used to do, like we just used to show some alert, but now with the help of AI models, we can interpret those alert and take further next kind of action. Same if my just the last example which I have shown you. So if my milk is about to get completed, what I can do, the AI model can interpret the command, and it can go and order the milk from any nearby grocery or something like that. Those kind of decisions it can take. Or say if there is some fire, the temperature sensor is giving a temperature, and smoke sensors are indicating like there is some fire. It goes to the cloud, it sends back to the actuator. Actuator started displaying alarm, or say playing alarm and all those things. But with the help of AI, we can take for the next kind of decisions, like turn on the like water sprinkler or something like that. So that, because now AI at least can think and interpret the context out of any message. So that is helping us a lot. Widespread 5G, like they are enabling high speed, okay, and low latency. So they will be very useful, because the latency which we were talking, when we are communicating with the cloud, the latency is a major constraint. With the help of widespread 5G, like that will help us a lot. And it's much more IoT friendly. The 5G is designed by keeping in the mind like it supports a lot of the IoT protocol. So that will further help us to increase the adoption of IoT devices. So with that, I will take a pause. Now I am open for your questions. Uh, Feel free to ask any question. Sir, I see a question by Dr. H. Somasekar. What is the difference between IPv4 and IPv6? Sir, it's basically both are the protocols used by the network layer. But IPv4 has a limited set of IPs, whereas the IPv6, the bytes used in the IPs are very high. So theoretically, we can with the using IPv6, we can assign IP to the every sand grain on this planet, whereas IPv4 we are having some limitation. So it's like That is the main difference. And then the communication protocol is also slightly different. IPv6 having more securities considering IPv4. Okay. Then Karthikeyan sir, how Fizz automatically order the missing thing, how the data flow will happen. Sir, here we can. So I talk about the application thing, correct? So when my sensor detects like the milk or anything is about to get completed or finished, it will send the data to the cloud. Then cloud will pass on that data to the any actuator, and then there can be a built-in actuator can communicate to any other small microcomputer which can basically go and basically order it with the help of some APIs, which most of the say grocery shop exposes, and it can go and order in that way. That logic we can develop, sir. Any other questions, sir? Feel free to unmute yourself and ask. I would love to answer that also. Manoj sir, I think there are no more questions. I might have missed few while giving the
Yes,
session
sir.
because yeah. So in case there are few more questions which comes after the session, feel free to sir collate and send it to me. I will answer
So
each
one
one.
question, so one
Yes.
question is there. Just asked in smart meter to detect power consume. What are the sensors we used?
Sir, in the smart meter to detect the power consumption, what are the sensor we use? Sir, like see, with any meter detects the power consumption. We already had that correct. So what smart meter was doing, it was detecting your reading, and it was relaying that information back to the electrical company, so that they need not to send any particular vendor to your home. I personally haven't worked on the smart meter, but in my opinion, like it could be some data communication uh, to the electrical company over cloud or something like that, where they were reading the since reading is anyway the smart meter, any normal meter was also displaying the data. So sensor was there. They might have put some more sensor or actuator which read the data from the sensor and sending it back to the electrical company. But I'm not very sure about it.
Yes, sir. You can go ahead.
Okay. So I sincerely thank all of you for your time on this busy evening. Okay. And listening to me. I have put my email ID on the slide at the introduction slide. Feel free to mail me if you have any question. I will try to answer as many as I can with my limited knowledge. With that, I say thanks to all of you. Thank you so much for your time. Thank you, Manoj sir and Rajshri ma'am and the entire Chamila Devi organization for giving me this opportunity to present my thoughts. Thank you all.
Thank you, sir. It was a pleasure having you among us today. It was really informative and insightful session. I'm sure our participants will carry back a lot of things with the session. And it was a pleasure connecting with you, sir. Thank you for your time.
Thank you, ma'am. Thank you all. Thank you so much.
Thank you, sir. Thank you so much.
Thank you.
Respected participants, we will start the session 2 as soon as our technical experts join us.
Sumit sir. Sumit sir.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. हाँ सर प्लीज कर रहा हूँ सर इनको आई थिंक अभिषेक सर इज ज्वाइन तो उनको सर अनम्यूट करके उनको कोच बना दीजिए सुमित सर आर यू देयर
Hi all.
सुमित
Thank you, Manoj sir.
Yeah.
Now I've been unmuted. So Manoj sir, like since we have some time, I
Yes,
would like I need your permission to share something about the work which we
yes,
are.
yes, yes, sir. You are most welcome. Welcome, sir.
Yes. Kindly allow me to.
Yes, sir. Please, please.
Yeah. So please enable screen sharing option also for me.
Okay, okay. Sumit sir. Sumit sir.
Sir, wait for 2 minutes. Sumit sir is currently offline.
Okay, okay.
He will make. है ना? Okay, okay. Abhishek sir, now you are co-host.
Okay. Thank you, sir. Thank you, Jina sir.
Thank you, sir.
So here's a bit about like the great work which we are doing, and I will explain a bit about like how we are helping India to be self-reliant, especially in the field of defense. So I will not take much time. I will make sure like we finish in next 20-25 minutes, and I will walk you through the deep tech solutions in defense, drones, and robotics, and also in edtech which we are doing. Okay. So this is a bit about my company. We started in 2018. We are from Indore, Madhya Pradesh. Our core vertical spans across UAV. That is our primary vertical. We are also in robotics, defense tech, and a small segment in the ed tech. Because what we believe, like we from border to schools, this is what our ideology. We should also give back to our society along with helping our soldiers. Our philosophy is very simple. We want to be the technical backbone of Atmanirbhar Bharat. We are heavily focusing on indigenous innovation, and our motto is to secure our country. Okay. Presence, like we have a good presence across country. We have deployed more than 500 UAV products across the Indian Army, Indian Air Force, Indian Navy, multiple states, police department, forest department, few universities, colleges, schools, NGOs and private firms. Okay, I also feel pride to share it. During the operations indoors, I was personally at some undisclosed location, helping our armed forces, and we have provided more than 55 grenade dropping drones to Indian Army during that conflict. So I feel a lot of proud to share this information with all of you.
Uh, Excuse me, sir. I have one question.
Yeah.
If the environment is dynamic, so how can we solve the problem of path planning?
Okay, sir. So, see, sir, path planning generally we do with the help of GPS, sir. Okay.
Okay,
So, what we do, like, since in most of the cases, if GPS is not blocked, sir, or you are within our country,
okay,
GPS will not be blocked. So, you can do the path planning using the GPS coordinate. We have developed our in-house Linux-based flight controller, where we have this facility. You simply specify the location, like you specify in the Google Maps. Sir. Pretty much similar way. You just tap on those point, and drone will go to that point, do whatever you instruct the drone to do, and it will come back. In
uh,
case, yeah, please go ahead.
yeah. If GPS, if there is some problem with GPS or not available due to some technical issue, then how the drone will handle this problem?
Yes, sir. So, so sir, we are handling it in multiple ways. The most common way when the GPS goes down, we immediately switch back to the manual mode because a drone will be drone generally a pilot is flying the drone. So the moment GPS goes bad or say blocked, pilot will have a manual control, so it can override the path the way it wants. It will also getting the live streaming throughout the journey. So all of our drone are transmitting the real-time videos also. Uh, so he or she will be seeing what is happening. That is one way. Say the communication is also blocked. Okay. In that case, as under such scenario, we also developing drones which solely relies on physics for the path planning. So you are flying a drone, sir. Okay. So if I talk about quadcopter, it's just about the four motors, which is making sure the drone is up in the air, and then these motors are responsible for the navigation of the drone in the forward direction, right direction, or left direction. So using those algorithms also, we can do a path planning like go 1 kilometer straight. In order to go 1 kilometer straight, I need to make. We can definitely decide how much each motor with how much RPM each motor should spin. So those kind of drones also we have provided to the Indian Army, sir, and they are being operational even as of now. I hope I answered your question.
Yeah, yeah, sir. Thank you, thank you. You can go ahead.
Sure, sir. Then, sir, these are our defense UAV and US capability. These are our drone fleets, sir. We believe in end-to-end design, development, and manufacturing of our indigenous UAV. Even like if you see the drones, you can like very easily figure out they are being self-designed and self-made. We believe in a solution-driven mindset because whenever say I'm creating something, it should solve current burning problem. That's what we do for the defense forces. We have multiple UAV solutions spanning for normal surveillance, then night surveillance, payload delivery, training, and research. So payload delivery can be, say, dropping a grenade or dropping something, some other payload. It can be any other payload. And then training and research purpose also, we are having few drones, which we are helping our defense forces to train on drones. We are also collaborating with multiple universities. We are establishing drone labs there, helping the engineering students to get hands-on experience on the drone. Because what I believe, it's a booming sector. There will be lot of the require. There will be lot of jobs coming up for the drone engineers and all those things. So we, in my ideology, what I believe is like students during their 4 years, they should also get some hands-on experience with the drone. Keeping that in mind, we have established drone lab in multiple places like IIT Indore, NIT Jaipur, few other private colleges which I won't name. But yeah, more than 100 plus such institutions are using our drone labs. Okay. We have in our indigenous remote control. We have underwater drones also, which can go inside the water. We have drones or RC which can work in the GPS denied environment, like as you already pointed out. And at the same time, we also have our anti-drone detection systems. So these are the drones in the fleet. So we can see like they are more than 70% indigenous. By indigenous, I mean the component which are more than 70% of the component Pfizer which manufacturing. Rest 30% we are importing from multiple places. We have these kind of drones. Pradhan is one of them, like which can be used for surveillance and recognition. It's a very fast drone. It can fly at a height of 1 kilometer also, where it's like almost very tough to detect by any radar also because the size is very small. It's just 7 inch, so it's almost undetectable at that height. It can work in GPS denied as well as anti-jam mode with the manual takeover, and it, needless to say, like it streams the real-time data. Similarly, Tapo, it's for like it's for thermal recognition, especially during the night when you have to do a surveillance where you need, say, in jungle or somewhere where it's very dense and you want to see some presence of human beings or some other thing. In that scenario, you will use Tapo. It's the dual, again, it's a dual thermal and normal camera. Vahak is our logistic drone, which you can use for multiple payload carrying capacity with 2 kg. It has grenade dropping mechanism, as I said. And all of our drones are fully autonomous. You can just program and forget about it. It will go, do its work, and come back. Then these are some defense projects which we are working, like Vachak is our indigenous remote control. It's non-jammable. So like you were saying that someone is generally what happens, like with a normal handle gun, the drone gets jammed and drone gets fall. So we created our indigenous Vachak remote control, which cannot be jammed because we are working on frequency hopping. So it's next to impossible. Needless to say, all of the product, whatever I am showing you, is live and being used at some places in the country. Then we have Jalakshak drone, which is underwater drone, and it can go up to 1 kilometer, uh, and roughly 2 hours is the, sorry, yeah, roughly 2 hours is the operating speed which you get. Okay, and it can also carry payload. And then we have GPS and RC denied drone, uh, which works in very adverse environments, and all of them have fail-safe and autonomous navigation. And we are also using AI with our drone. Like during the IoT session, I was telling you, like there is one scenario where in the Goa we are using drones which can detect human being drone. So that is a good example of how like Internet of Things works. Drone is flying, it's capturing the data using camera sensors. Then onboard microcomputer is reading data from the camera sensor and detecting if someone is being drawn or not. Then using LoRa, we are communicating with the ground station. So that completes the IoT cycle also. We also have our anti-drone system, which is capable of detecting any drone in the vicinity of 1 to 1.5 kilometer. Okay, so any anti-drone is having three parts. First part is detection and identification, where we detect something. The second part is like neutralization. We can neutralize any incoming drone. We lack the neutralization thing with us. We have the capability of detection and tracking. So I will play a few videos for you. You can see the stability of the. I was trying to bring it down. Not only me, even I handed my stick to a soldier who was trying to bring it down, but he cannot bring it down. That level of stability are with drone. This is our fast flying Nabrakchak drone, which can fly at a very high. And we also operate at very high altitude, where you see this is this area. I will not disclose the location, but this is at 13,000 feet above the ground. It's very remote place in India. Uh, so our drone works in those harsh environment also, apart from the normal environment. Now coming to the training and labs, where we do collaborate with colleges also. And if some of you wanted to collaborate with me or my company, you're most welcome. We can discuss that later. So we have deployed more than 100 plus drone UV labs pan India in military organization as well as in schools and colleges. These are some things. These are some pictures depicting how does it look like the drone lab and all those things. Okay. Uh, you can see most of the premier institutes are using our thing. Uh, we also help, yeah, basically UV pilot training modules we give to the persons who want to get trained on the UV, because generally flying a drone, when you fly on a real drone without having any knowledge, you will destroy the drone. So we have some simulators which you provide, and using that simulator, first you can practice on the simulator and then you can try on the real drone. So that kind of customization is also there. We do provide comprehensive learning experience. Like apart from the hardware, we provide a curriculum also, like what needs to be taught and when it needs to be taught. We do train faculties also. Okay, and we also have customized defense training programs tailored for scientists, armed force personnel, and specialized in it. Then from the drone vertical, we also have a tech vertical, which I was talking about. So we have applied patent for this device. We call it Saral 3D. So it gives like 3D visualization experience. As you can see, like this Chandrayaan is not the real Chandrayaan. This is generated by our 3D model, 3D device called Saral, which help you to bring any 3D model in real classroom. And students are benefiting a lot. Not only students, it's being heavily used in the medical fraternity, because when any if you want to explain about any complex human organ, you can, with the help of this device, you can explain it in 3D. Needless to say, it's completely it's been seen with the naked eye. No specific device, nothing is needed. You can just see it with the naked eye, and it's very much it's been approved by a medical board also. It's very cost effective. It can be heavily used for training, or like any complex model. Say you are from say automobile industry, you want to explain about multiple engines and all those things. You cannot bring all those engines in one training, but with the help of Saral, you can create 3D model and explain them in the 3D. You can rotate it in any direction. How does it look from front, back, or any particular angle? So it's completely, you can rotate in 360 degree. You can zoom in and zoom out. Those kind of thing. This is also being used by defense forces for some of their use cases. uh, with God blessing and like support from everyone, we are like now we are with a renowned company. I feel pride to say like more than 200 times in last 3 to 4 years we have been covered by multiple newspapers, multiple media agencies, live interface and all. So whenever we believe in simple one thing, like whenever we do the good work, it automatically gets spread to everyone. Okay. Since we are from Indore, we have a very close collaboration with Indore police and all. Like a couple of things, like when there was a big event in the Indore during November 24th to 29th, when there are multiple delegates from 76, 79 countries came at the end of that time. Our anti-drone system was at a high-rise building, was detecting any incoming hostile drones. When Honorable Vice President visited, our anti-drone system was installed at Indore Airport for to detect any incoming hostile drones. So that level of operation, high-tech operations, our drones or anti-drone solutions are being used in those scenarios. I will skip this slide. Now, why Pfizer? Actually, we believe in innovation. So we are 100% indigenous R&D and manufacturing. We have a proven track record with multiple organizations, defense and government. We have multi-domain expertise like UAV, robotics, AIR, computer vision, underwater drones, and edtech. Needless to say, like we are fully compliant with all of the certifications, whether it's OEM certificate, GEM compliance, and we are very much committed to be the technical backbone of self-reliant India. That's what our motto is also. This is a bit about our team. Being the CEO and CTO of the company, I lead the entire development as well as the expansion of the business and the government vertical. Durgesh is my another partner who is CEO and CFO. He takes care of sales, finances, and other engagements. Rosni is the chief people officer of the company, and she takes care of people and other HR related activity, and as well as the media department. So that's a bit about our company. Feel free to reach out to me on the first number if you have any query or anything you want to connect. This is my personal email ID. You can mail me also if you want. So that was a bit about my company, about the work we do. Now I would love to answer a question on drone or any upcoming technology if you want to ask related to drone or IoT. I am open to answer that.
Excuse me, sir.
Yes, sir.
Sir, what are the internship opportunities for BTech final year students in your company?
Okay. So, sir, with student actually we do a internship. Okay. Uh, we select deserving candidates who are mainly from electronic and computer or mechanical background, and then we onboard them. It's generally 6 month internship. Okay,
Okay.
and, where we give them an opportunity to work on real-time projects like drone or anti-drone and any other upcoming technology. They gain insights how industry works and what is the current trend, technological trend. So there are opportunities.
Okay. And sir, what you are looking means for the internship, those who are applying for internship, basically, what are your requirements?
So, sir, basically depends on the stream from which student is coming. Say if it's coming from AI or computer domain, sir, we expect them to be a good programmer, either in AI or normal C language, because C is the language which is mainly used with the hardware.
Okay.
If it's coming from the electronic background, sir, we expect them to have some ideas of sensors and basic electronic concepts like communication and sensor, because these are we use in drones, sir. And if it's from mechanical background, sir, we expect him to good with the mechanical components like designing and all, because with drone aerodynamics also play a major role, sir. So these are the three branches. But apart from Raj, if a student is very enthusiastic and eager to work and eager to learn and have some experience, we would love to consider him also for internship. That should not be a problem, sir. Like,
Okay, sir. Thank you. So there is something autonomous delivery application. There are various autonomous delivery applications. So, sir,
yes, sir.
is there are some challenges?
So,
In,
yeah. So with autonomous delivery systems, sir, we do not face many challenges. There is one major challenge is, sir, compliances,
okay,
because so far there is no clear guideline from DGCA on how the delivery drone should be. They specifically mention line of sight. Now, if you want to deliver something beyond 4 or 5 kilometers, it should be beyond line of sight. So there is not much guidance. We tried couple of delivering in Indore with permission from respective authorities. We were able to do that, sir, but we couldn't scale because there is no clear-cut guideline. But I am very optimistic. Like in some cities like Gurgaon and all, some deliveries also started. Like we have the capability. It's just the logistic and some compliances we need to look into that. It works very simple principle, sir. Like you just feed the coordinate, drone will go to that particular position, and it will perform a certain action when it reaches that particular coordinate. Say you want to drop, it will drop the packet, or you want to deliver it through pulley or some mechanism, it will deliver via pulley or something like that.
Okay, thank you, sir. Thank you. Participants, you can raise your question in chat box if you have any question. So we'll wait for the 2 minutes if there are some questions in the chat box.
Yes, sir.
Yeah. Thank you. So one question is there. Hello.
Yes, sir. Please go ahead.
Sir, the question is, if there is a heavy rain condition, so how drone can manage that situation?
Okay, sir. So, sir, in those conditions, we need drone which are resistant to water. So there are some IP rating which comes with drone. So, so we need to create drone which can serve in that weather. Generally, most of drones are water resistant because BLDC motors they can sustain mild drizzling, sir. Then the brain of the drone, which we call the flight controller, it should be designed in such a way like it should be able to sustain the heavy rain. Basically, there should not be any water leakage. If we design the canopy in such a way, it can withstand the heavy rain. With heavy rain, there are few other challenges also. Air density changes. There is lot of mechanical pressure also which comes on the drone because water droplet also inserts lot of pressure on the drone. Correct? Apart from the normal weight of the drone. So this is challenging. So far, we have been able to fly in drizzling, but we also don't have capability to fly in very heavy drones.
So one more question is there. Is there any paid internship also, you are providing for students?
Yes, sir. So, sir, like I think one ma'am raised this question. A student can apply internship by sending a mail either to me or Durgesh, which email ID or Pfizer@pfizer.com. Stipend and all depend on the student's capabilities, sir, like how much technical work with him. But I want to make it very clear: we will not take any single penny from the student. That is not our business model.
Yeah.
We want student to learn and grow.
Okay.
We may pay or we may not pay. That depends on the student's capability and the dedication and how much time he or she can spare. But yeah, it's absolutely free. There is no charge for that. We will not charge a single penny.
Sir, kindly share your official email ID for students so that means anybody who is interested to apply for internship.
Yes, sir. I have just
Yeah.
pasted in the chat, sir.
Yeah. Thank you, sir. So I think, sir, there are no more questions. Thank you so much, sir, for sparing your valuable time, and it was a wonderful session.
Thank you, sir.
Yeah.
Thank you, sir, and thank you all respected dignitaries. It was pleasure connecting with all of you. Let's stay in touch, and like if you have anything, feel free to drop a mail.
Okay.
Sure. Thank you, sir. Thank you so much.
Thank you, ma'am. Thank you all.
For the second technical session, we have among us Mr. Siddharth Tungare, sir. He is a senior technology leader and strategic at Cleartails Technology in Indore. He specializes in the areas of DevOps, data optimization, technology strategy. He's an expert in programming tools, smart devices, and security issues, often invited to speak at industry and academics. He has completed his master's from DAVV and has also been a part of executive programs at IIM Indore and IIM Ahmedabad. He brings in experience from many job roles at different firms with a vast skill set that includes Spring Framework, Performance Java, requirement analysis, and more. It is a pleasure to connect with you, sir. I would like to request sir for the next technical session. Sir, please.
Hi, thank you, ma'am. Thank you for the kind introduction. I hope I'm audible clearly.
Yes, sir, you
Yes,
are
sir, it's
audible.
audible. Yes, sir.
Okay, so let me try and share my presentation immediately. Allow me a minute. Okay, please confirm once my screen is
Yes, sir,
visible.
visible. It's
Yes,
visible.
sir. Yes, sir. It's visible, sir.
Okay, so let me know when I can start.
Yes, sir. You can start, sir.
Okay, all right. Thank you very much, and good evening, everyone.
Good evening, sir.
So, I would be walking through, very, very fascinating world of Internet of Things. And as we move on with this session, most of us will realize that we are part of this wonderful phenomenon, wonderful concept, knowingly or unknowingly. And on a daily basis, we are contributing towards huge data building, which is now being trained for a lot of internet enabled devices. They could be wearable gadgets or smartphones or whatnot. What we'll do is we'll talk about some of the programming tools for Internet of Things, or IoT as is more commonly called. We'll talk about what devices we are surrounded with, what type of applications do we have. After that, we'll talk about Internet of Things cloud, IoT cloud. And then the most critical thing which would come into picture would be the IoT security issue. So, as I said, a lot of devices surround us on a daily basis. What we use, our smart cars, our smart watches, smartphones, whatnot, at a runtime, in real time, they're sending data, they're capturing data and sending data. Where is it sending data? We'll come to that part. But at any given point of time, as like blood flows through our vessels, in the same manner data is flowing across. It is just that that is something we cannot see, but that's happening. And IoT is it's I would say after the industrial revolution probably is going to be the next big thing. People are these days talking about AI and Gen AI and whatnot. But the basis of everything is going to be IoT. So after internet, after industrial revolution, and then after internet, probably Internet of Things is going to be the next big thing. It is already happening, and we'll talk through it, how it goes. But there are some funny quotes, which surround about Internet of Things. So those quotes are something like this. Uh, See, everything is connected except your toaster. A very, very funny and very popular quote in the US, especially. People talk about each of your devices is now connected to internet. Your fridge may be connected, your microwave may be connected, whatnot. Your gas may be connected, etc., etc. The scale at which people are talking about. So we've been hearing about smart cities now, a very common thing. Fortunately, I think Indore is being selected as one of these smart cities, and it would be developed on the similar lines. to smart socks. It may sound as fiction. What does smart socks mean? But trust me, when I give you the example, probably things will start making sense to you what I'm really talking about. More devices and more data. So, as I said, that we are living in a connected world, and the moment we are connected to the internet, data exchange starts happening. And well, is it dangerous? Is it safe for us? Who knows? I mean, that's an open question, and we will talk about it now. It's not the future we are talking about, or it's not the science fiction we are talking about. It's already here. And as I said, some of us, we realize how we are connected with the Internet of Things, or how the things are connected to Internet. But you know what? I mean, most of the things we deal today are responsible for contributing in this domain. And now, earlier we used to say that when humans talk, machines listen. But now is the other case. When machines talk, humans listen. Very simple example I'll give you. When somebody is using a GPS in the car and the GPS is talking back, it's not the human who's talking to the GPS. It is the machine which is talking, and we are listening to the directions. Of course, now with the smart cars and whatnot, self-driving cars, probably the machine will not even talk to the human beings, but it will directly talk to the machine. So it will be a machine-to-machine talk, and the cars will drive themselves as they are doing. Unfortunately, this morning I read about that. Tesla is not very successful in India so far. They should have sold about what 2,500 units, but the Winnie will to sell about 600 units so far. So that's something, probably the price point and everything. But capability wise, I mean, the machines are already here, and probably the next generation. I mean, I can definitely. So right now I have about 21 years of industry experience. So when I was in college, uh, we used to read online, a bit online, but most of the stuff was still physical books. And now, if you talk about, then people are already talking about audible books, where you don't even have to go through the pain of reading a book. So from physical books came e-books, then this Amazon Kindle was there, and electronic media took over everything. But now it is like you have applications like Audible, who can read the books to you, and you can listen to the books at your own pace. So that kind of revolution is happening. But when we think about this, it sounds to us, it looks, I mean, the devices, they look fascinating to us, don't they? Like, say, for example, if I'm talking to a device, Alexa, for example, then it is so fascinating that I ask some question to Alexa, Alexa answers that, and this entire interaction becomes very, very engaging, right? Intriguing. But essentially, what happens in the background is even more intriguing and even more baffling. It is the data which is getting captured as part of our communication, our interaction with the device. Let me give you a very simple example. So all of us, at least, I mean, I'm assuming most people from my generation now, they are heavily into online shopping, right? Amazon and Flipkart and whatnot, and now the express deliveries with Zepto and Blinkit and whatnot. So ever wondered, I mean, try to browse on Amazon.com. Let's say, for example, I'm searching for a particular type of computer. Okay. Next moment, you open your another browser, and let's say open Facebook or some other page where there are ads enabled, and all of a sudden you'll start seeing that you see suggestive ads, suggestions, recommendations for different computers which you looked for, which you searched for in your Amazon.com application, or any online application, shopping application. That is where the things really get scary, because you look for one thing, it starts suggesting multiple things based on your preference. So probably what I'm searching for at the moment may be completely different from what my kids are searching or my wife is searching, and their recommendation could be completely customized for them. And that is where I see that it is the data that is getting transferred as part of the communication between the devices is the real revolution. But then what exactly drives IoT, right? There must be something which drives IoT, something like infrastructure, or there could be some machines or whatnot. So let's take a look at that. So basically, it's a lot of sensors which really make IoT tick. Sensors which are capable of collecting data, which are capable of providing the connectivity and then adding the intelligence. And when we talk about IoT in action, then we have something called as the concept of smart homes. A very, very dear friend of mine, the family, they run a smart home company based out of Indore, but very, very proud to say that one of their customers is one of the biggest hotels in the world, which is Burj Al Arab, and the tallest building, Burj Khalifa. They are responsible for providing the smart automation solutions for those two structures. Then we have IoT in action when we talk about healthcare. You know, so if I'm talking about healthcare, then what happens is that I have, like, for example, there are electronic gadgets which I'm wearing, and these gadgets actually are responsible for transferring my health data to the various applications. So I would kindly request a minute. I'm getting a phone call from work. I just need to answer that. Will that be okay, please?
No issues, sir. Sir, you can surely take it.
Yeah, I'm really sorry. I'm back. Uh, so I believe I'm audible, still audible.
Yes, sir, you're
Hello.
audible, sir. You can continue.
Okay.
Yes, sir, it's audible.
Yeah. Thanks for confirming. So, as I said, so IoT is when in action. We talked about smart homes, we talked about healthcare, but agriculture is one very important thing. And in countries like Israel, where there is scarcity of land, they have something called as vertical agriculture. They grow their crops vertically on walls. Okay, and the way it works is like they have their entire plantation grown up vertically, and obviously, I mean, with all the automation available, what happens is the temperature of the soil, the crop quality, everything is monitored in real time. Watering of those crops and everything that happens in real time. So those sensors all the time, they keep on collecting data, send it to their analytics center, And once that is analyzed, it takes the necessary action. Why we say that data is the new oil, you know there was a old saying, when oil was discovered, or rather when oil was discovered. So uh, there was an old saying in the stock markets in the United States especially, that if you can predict the price of the crude oil, then you can predict actually anything. You can be the king on the stock market. And why it was said so? Because oil is the backbone of the economy. Believe it or not, even today, although we talk about electric cars and whatnot, but the prices of oil usually controls the price of all the commodities around. Uh, and that is why now they are saying that data is the new oil. If you have a lot of data and you can analyze that data. So, for example, if I have all the patterns of a stock market for past 10, 15, 20 years, I have sufficiently advanced algorithms to tell me how my data trend has been, how my stock trend has been, and then how am I going to go about, predicting the next stock, scale up or scale down, or a rise or fall in the stock market. Obviously, it can be, it obviously will be predictive, but it will be based on pattern. Similarly, if I tell you that, in next 10 days, there would be a scarcity of, let's say, milk supply in my city. Okay. So a smart shopkeeper, what he or she may do is they may stock up on milk, and when there is scarcity of it, they may sell it out. I'm not saying doing black marketing thing, but they can sell it out even at nominal price and gain sufficient profits, because elsewhere it is not available. So people are bound to buy from that particular shop only. So that's how data is going to be the next big thing, is already the next big thing, by the way. And anyone who has the ability to mine that data is going to be the king. I mean, mining gold was thing of the past. Mining data is the thing of future, present and future. We talk about real-time responsiveness, right? So self-driving cars is a classic example. uh, the sensors are catching up where, how far is the other vehicle from my vehicle, is it within a safe driving zone or not, safe distance or not. And at any point of the time, if the sensor senses that there is going to be a collision, then from a reactive system or from a predictive system to a reactive system, what happens is it will apply the brakes, right? It won't spend any time in thinking what should I do in that condition. So that is the real time responsiveness. But with all this immense power comes a lot of challenges of security, scalability, interoperability, right? Yeah, I joined this session a bit early, and I was listening to the insights shared on the drone by the earlier speaker, and there you see, I mean, that is one more way in which things are getting delivered to people. Automated drones are delivering things to people. So that interoperability between humans and the machines and whatnot. So those many challenges are there. So essentially, then what happens is, which way essentially are we heading? Are we heading the artificial intelligence way, or are we heading the IoT way? And there is no clear cut answer in black and white, but we are definitely moving towards an autonomous ecosystem. What that means is that, I'll be very honest with you. Uh, I created this entire presentation using Gen AI. I started giving what exactly I was looking at, and I wanted to create a presentation. I wanted to try how accurate this presentation is created by Gen AI. And then I compared it with my notes, and I was pleasantly surprised that, whatever of course, you have to give as much accurate query as possible to the Gen AI system, and it would give you with as much accurate answer as possible. So that's where we are headed. I mean, autonomous ecosystems. How many of you have heard about IBM's Watson computer, robotic computer? I mean, that computer was trained even to fight, even to contest court cases in the US, and it was pretty accurate. So that is where the autonomous ecosystems are now moving. If I talk about then the architecture and data flow, so the IoT architecture essentially moves from edge to cloud. Edge means the starting point from where I'm collecting the data, which is my sensor, and it is being sent, stored on the cloud, stored across different nodes and whatnot. So that is how the IoT architecture is, from edge, which is from its collection point to its final destination, where it is being analyzed and the response is sent back again to the edge. Uh, Obviously, whenever we are capturing information or transferring data, there has to be protocols. Like, for example, when we are talking about internet, then there are HTTP, HTTPS protocols. So similarly, there are protocols for IoT, Wi-Fi, Zigbee, NB-IoT, etc. One question may come to your mind is, where exactly does the thinking happen? I mean, edge or cloud computing? So most of the time, the computing happens in the back end of the system, but edge is the front end of the system, which collects your data. But now with smartness being built at the front end as well, it is capable of thinking, doing at least a basic thinking, if not very heavy computing. It can do a basic thinking and process the data and give the result for you then and there itself. What's the life cycle of the data? Very simple. You capture the data, which means you collect it at the sensor level. You transmit the data, you store the data, you analyze, and you act. When I say you act, at that time, basically you are taking an action based on your analytics, which has been performed on the collected data, which has been stored, which was transmitted to this present, present state via some protocol or via some medium. And then you have the middleware, which keeps the entire system together. And you have then APIs which allow you to do interoperability, which makes devices play nice. I mean, when I say devices play nice, that means is it provides you the output of the device. So you have different APIs. For example, for your touch screen phone, right? You have a user interface, which is the front end, on which you insert your input, and through application programmable interfaces, that call is being transferred to your backend, is processed, and the result is being published to your front end. So, by the way, how am I supposed to take the questions? I mean, should I run through all the slides and then take the questions at the end? Is that how we would proceed?
Sir, if there is any question in the chat box, definitely I will raise the questions.
Okay, because I cannot see the chat box, I'm just seeing the entire screen. So,
Sumit sir, is it possible so that sir could see the chat box?
No, I mean, I can see the chat box if I go to the other screen.
Okay.
Fine. Right
definitely,
now,
sir,
yeah.
I will raise the questions.
Okay, fine.
So
let me know whenever there is a question, and I'll
definitely, sir. Definitely, I am looking.
Okay, perfect. Thank you very much. So now diving deep into the real world IoT applications, right? Smart cities, I don't know what they are exactly going to do with Indore, but definitely what I know is traffic lights is something. So, in earlier days, traffic lights were...
Sir, one question is there.
Sure.
Yeah.
I'll take that question.
How API will help us to communicate with other devices?
Okay. So, see, API or the application programmable interface basically gives you an endpoint. Okay. Let me take an example. Uh, how many of us are aware of a protocol called REST protocol or RESTful protocol? That is one protocol essentially which allows you the ability to program and take the data along with it, and that transforms this programmable data. I mean, whatever data we are providing through that programmable application, it transfers that data into the device, takes back the output from the device, and then sends it back to the whatever output console we have.
So I
So
think used for distributed systems. This that you are talking about.
yeah, that is used for the distributed system.
Distributed
That
system.
is correct.
Yeah, yeah.
Correct. And then what happens is, so this interface, as I said, API is an interface, right? So this interface will essentially allow me to program in the language which my device will understand, and then it gives me the response which can be transferred across to the user. So, I mean, I can add more details to this if required. So, uh, when I talk about any application programming interfaces, right? So, essentially, what they do is they help us to send the commands to devices. For example, if I'm sending a signal to a device, which would say that turn a particular device on, okay? In such case, what will happen is that sensor will send the signal to the device, which will in turn turn on the signal or turn off the signal, turn on the light or turn off the light. In a similar way that I have my thermostat, which can be used to control the air conditioning temperature. So when I'm pressing the buttons on my remote control, the remote control is programmed in advance using APIs, right? So those APIs, when I press the button and when a data is inserted into that remote control, that data is transferred into an actionable entity, and that in turn takes the action, whichever is the required action. So, in a higher sense, in a broader way, this is how APIs help us to interact with the devices by sending the signal, by receiving the data, and even by managing the devices. So, I hope that answers the
Yeah,
question to some
yeah.
extent.
Yes, sir. Yes, sir. Thank you, sir.
So as I talked about traffic lights, right? So in earlier days, what used to happen, the traffic lights, their programming was done based on the pattern, and they were pre-programmed. Say, for example, people who are well aware with Indore, I can take that example for them. Say, for example, the timing at, say, Palacia signal in the morning is during office hours would be slightly higher as compared to the timing on the same signal during night hours, say after 11 o'clock, because there is very less traffic at that time. Now, what these smart traffic lights would do is they will continuously analyze the pattern of the traffic which is coming on that signal, and at real time would transmit that data to the backend system. The backend system will process that entire data and then send across that actionable back to that traffic light. So, for example, if the system is observing a lot of a traffic jam happening or is predicting a lot of traffic jam happening in the system, then what it will do is it will accordingly take the action for turning the traffic light on for a longer duration or whatnot. Similarly, connected healthcare, as I said, so wearables that save lives Apple Watch is one example. Some of you may have seen the Apple launch event yesterday with the new Apple Watch predicting, your pattern of your heart functioning and your breathe analysis and whatnot. Precision engineering, precision agriculture, rather. I talked already about it. Smart homes, for example. You can program your homes in such a manner that when you leave for the office in the morning, you don't have to worry about did you turn off that particular light or not. It will automatically, and you can control this through your smartphones. You can send signals. Air conditioners are available, geysers are available nowadays, which can be controlled through your mobile phone applications. Before reaching home, you can turn off the geyser to get you warm water when you reach home and whatnot. Machines, for example, self-report machines. So when, for example, in an assembly line, say for example, a particular machine breaks down, then it generates a self-report and the entire assembly line stops instead of, uh, damaging the rest of the assembly line. And then there are self-healing systems. The system determines if there is a problem in the entire cycle, and if it senses a problem, it immediately stops for the system to heal automatically. For example, in computers, the most common way of self-healing system which we design is we keep looking for the CPU and the memory usage of a computer. And if we see that those resources are getting too much used, then what essentially we do is we take the corrective action of killing or stopping unrequired programs so that we can free up memory and we can free up CPU for other applications to run. Similarly, connected mobility we spoke about, and car talking to roads is a bit of a stretch. I mean, that is too much of advanced thing we are talking about. But as I said, I mean, anything appears to be fiction till that turns into reality. And who knows? I mean, we could very soon have cars which are talking to roads. Roads are set, I mean, talking not as in we are talking to each other, but they're sending signals to the road, getting back the signals from the road, and accordingly they are getting auto driven. So that is one thing which is one of the real life examples for IoT. So moving on, why do we require programming for IoT? I mean, everything is working fine, then why do we require programming for IoT? So we require programming for IoT because whatever is working for us right now has been programmed by somebody for us. And if we want to control our devices, what is the best way to control something? The best way to control something is you need to understand the language of that particular thing, and you should be able to train that thing to get the desired output.
Sir,
I mean,
one question is there. Sir, I have one
sure.
question. May I ask?
Mhm. Yeah, please go ahead.
How does IoT devices detect failure before it becomes critical, as far
Oh,
as the
that's yeah.
performance is concerned?
Can you are you talking about any specific device or any uh, device in general? So I can
In
answer that question.
general question, sir.
General question.
Yeah.
Okay, that's a fantastic question. Let me give more insight into it, and let me know if I understand this correctly. How does an IoT device understands a problem
Yeah.
and acts before it becomes a fatal problem
Yeah,
for the
yeah, yeah.
system?
Yes, sir. Yes, sir. Absolutely right.
Okay. So see what the IoT device is doing, what I said in the beginning, it is collecting the data at real time and it is processing that data for patterns in the backend, right? Now what happens is these devices and this entire pattern is a part of a self-learning algorithm. We have a very famous saying that people usually learn from their mistakes. This device or this entire system exactly works on the same pattern. They learn from their previous mistakes. So they learn from what went wrong and what should not be done. And if they sense that all the parameters in my system are exactly the similar way like they were 10 days before, and when the system showed these symptoms, then my system went rogue on me, it went down. So this thing takes that action and the corrective actions are already fed into that system. Say, for example, let me give a very vague example. On our, let's say, on our vehicle tire, there is a signal mentioned that maximum pressure this tire can withstand is XYZ PSI. So what a IoT device will do is, say I have an IoT device fitted on my tire inflator. What it will do is, it will keep inflating the tire till it reaches that particular threshold. And once it reaches that threshold, my system knows that if I inflate the tire beyond this threshold, the tire is going to burst. So the signal will be sent to the device that now stop pushing air into the device, into the tire. Otherwise, the tire may burst. And at this point, it stops inflating the tire. This is exactly the same way the system looks for patterns in the system, and if it sees the patterns, then it takes the corrective action. However, if some pattern is first time for the system, then obviously the system may fail, and but it just simply doesn't fail. It captures all the readings, all the parameters, and it feeds into the system so that the system can next time, whenever any such parameters are there, they would actually take the corrective action. Very simple example, like if we see dark clouds outside, immediately our mom calls for us that, get the clothes inside, otherwise it may rain and they may get wet. This thing has been embedded into our system right from our childhood. How did our mother know that when it becomes dark, it will rain? Or how did she know that if it rains, the clothes will get wet? It must have happened sometime in the past, and from
Past
that
experience.
experience, they tell us, right, that
Yeah.
this is going to happen.
Yeah.
That's exactly what the machines are doing for us today.
Yeah. Sir, one more question is there in chat box.
Sure.
Difference between IoT and M2M communication applications.
And I see one more thing, that it means it thinks like humans. Firoz ma'am, I'll answer that question. I like that question very much. But before that, let me answer Karthikeyan sir's question. IoT and M2M communication application. So M2M communication applications are something which, the actions are directly, the actions or the decision making is sent to the machine only. And there are two machines which are talking to each other. While in IoT, in most of the other cases, at some point or at some end, a human being is the recipient of that particular service. So, smart home, if I click something, the lights turn on in my home. So obviously, I mean, my machine, my application on my mobile device is talking to my home automation system. But who's getting benefited by it? I'm getting benefited because before I reach my home, my lights are turned on for me. Or the burglar alarm, right? If somebody tries to break into my house, obviously it is a machine-to-machine communication. But then the communication is made to, the hooter beeps or something happens, and what essentially who's getting benefited is the human being in that case, right? So that essentially is what happens between an IoT device. That's the difference between an IoT device and M2M communication. Uh, Now, the second question is, does it mean that it thinks like human? Ma'am, way beyond humans. Only difference is that people are yet to, I mean, obviously people have started embedding ability in the machines to show emotions as well. But machines are machines, right? Even if you build an emotion into a machine, and a machine simulates crying, it is not the same. Or if it simulates laughter or happiness, it is not something which is exactly same as what we experience in human beings. If I feel happy, I make 10 people feel happy around me. But if I feel sad, probably, I mean, people around me would feel sad and whatnot. So that is one difference. But in terms of thinking, yes, they do think like human beings, and they analyze way more powerfully than a human being would do. So that is one more difference. But yeah,
Sir,
the principle is same.
one question is there from my side. Sir, what
Sure.
are the different communication protocols generally we use for self-reporting devices?
Oh, we'll come to that. I have that
Okay,
covered in
okay,
the
okay,
upcoming
fine,
slide. So
fine.
we'll come to that.
Thank you.
Yeah. So we talked about the need for programming in this slide, right? So basically, I mean, if I want the system to behave in a particular manner, I would need to know the system. I would need to know the language to talk to the system, and I would need ability to program the system, right? Now, what different tools are available for doing this? It really depends on what type of device I am building or what type of device I am trying to program. But at the core of a lot of IoT systems, embedded systems is the heart of every system. And most of people of my generation, at least, will still feel happy about, because C and C++ has been the mother tongue for most of us since we started learning computer science. And all the major chips, even today, they are programmed using low level machine learning, and they are controlled using programs written in C and C++. Specific specific development environments like Eclipse we use for Java. Similarly, Arduino IDE is available for certain type of Arduino boards. Some of you may have heard about a Raspberry Pi systems. So programming interfaces are available for them. Then for more advanced chipsets and frameworks, Platform IO is there. STM32 Cube IDE. These are for microcontrollers, obviously, for advanced devices within your smart devices. But one popular one which I have seen in the past is for PIC microcontrollers, and that is MPLabX. That is one very cool development tool and environment it produces for building a robust IoT system. There are other tools like, I mean, you can even program using Python, for example. And then there are different cloud SDKs or standard development kits available. Communication protocols, I'll come to that, but the simulation tools are available. So even before you actually try your hands on to a particular device, you can simulate the behavior so that you don't break the actual device. And all these simulations are available. So for example, if you're simulating software for a lift, right? Now, you really don't want to try it out first time on a real lift, because what if it fails? I mean, it may break and cost you thousands of rupees, right? Or lakhs of rupees for that matter. So you have simulation tools. What do you think? I mean, the Chandrayaan and the rockets and what all we sent to the space, all of that, the aeroplanes which are flown, all of them are tested using simulators first. And once that simulation is done perfectly, only then things are tried on the real devices. So that is what we have in terms of how advanced these different tools would be. So I spoke about these programming languages, C and C++ for low-level device control and firmwares, essentially. Why C, C++? Because it is fast. It is very, very memory efficient. So somebody who comes from a Java world may say that, memory is a big problem. But in C, C++, I mean, people have built programs in a few kilobytes and few megabytes of memory, while Java, initial memory usage starts at 1 GB, 2 GB, and whatnot. But there are different applications in which Java plays well as compared to some other thing, because Java is portable, Java is easily scalable. Then you have something called as Python. Python, because it has a very, very rich set of libraries. And you talk to any data scientist, and they will, even if the data scientist speaks Hindi in his house, he will still say Python is my mother tongue, because Python is something which is being used by them and it provides such a high level of programmable interface that it becomes programming with Python becomes really blissful for data scientists. JavaScript, obviously, for your web dashboards and user interfaces, and Java, as I said, for your enterprise systems. So all those things are available for your disposal. I spoke about cloud SDKs and platform SDKs. So here are some examples on that. So for example, you have something from AWS or the Amazon Web Services, which provides you some core standard development kits, which can be used for device provisioning or multi-queued messaging services. They can be used for putting rule engines and whatnot, writing rule engines, not putting rule engines, writing rule engines. Microsoft Azure, it provides its own SDK which can integrate with services like Stream Analytics. Now, what is Stream Analytics? It is a service provided by Microsoft Azure for streaming real-time data, and it can provide you interfaces or the APIs to write programmable interfaces for your Azure SDKs, using Azure SDKs rather. Google Cloud has its own SDKs, and Blink is another open source platform that gives you ability to create rich dashboards and gives you different type of device controls and whatnot. These are the communication protocol libraries, which are heavily used in the world of IoT. I'll start with the most common one, which is HTTP and WebSockets, because excuse me. HTTP, obviously, we all know hypertext transmission protocol used in internet, and WebSockets. All of us who have studied microprocessors, we know we have done socket-based programming, controlling various printers, various ports, and whatnot. You have something called as MQTT, where a multi-queued applications where we are transmitting huge data in terms of queues, right? So those protocols can be used, and they're very lightweight essentially for cloud messaging. There are three common parts to MQTT. There is a publisher, which sends the data. There is a broker, which routes the data between publisher, and then there is a subscriber, which receives the data. So I hope you all will be able to recall the producer-consumer problem, which we all used to study in operating system.
Yes, sir.
Yeah, similar thing is something called as a publisher subscriber model, which is now being taught in the recent curriculum in IoT. You publish a message to a topic, that topic consumes it, it receives update, the broker handles all the routing and whatnot. So that is MQTT. Then you have something called as COAP, or something used for RESTful protocol optimization. Again, this is very when you have something called as battery powered devices or sensors, right? Because this is a very low power friendly protocol, COAP is used in those devices. Wearable gadgets, watches, your Fitbit devices and whatnot, they make use of COAP. And this is a RESTful protocol, so it provides support for your get API, post method, put method, whatnot. And instead of UDP, or rather instead of TCP or transmission control protocol, it uses UDP, or the user datagram protocol, which makes it very, very lightweight, and it's heavily reliable because it completely works on the acknowledgement and retransmission methods. So these are some protocols, commonly used protocols. And there are a couple of more like Zigbee and LoRa libraries for short range and long range wireless transmission. BLE is Bluetooth Low Energy Protocol, and use cases for this is health monitors, smart locks, then your wearable devices like your fitness tracker, smart watches, and whatnot. Zigbee is again very low power, low data wireless protocol, and it is used for smart lighting systems or home security systems, and supports kind of mesh network, and uses very less power, operates somewhere in the range of 2.5 or 4 gigahertz, so common to what internet frequency or wireless modems operate at. And it can handle hundreds and thousands of devices in a single network because it is very lightweight. So that is how it can handle. So let's move on. Then, as I said, there are simulation and testing tools. Obviously, you would want to simulate certain things before trying it on the actual device. So you have these Tinkercad circuits to simulate your Arduino projects and virtual components. Then you have Proteus for circuit simulation. Obviously, you don't want to burn your circuits, right? With incorrect configurations. So this can give you a good amount of simulation and can give you exactly what kind of behavior your circuit is going to show. PCB
Yes.
or chip
Excuse me, sir.
design.
One question I have.
Sure.
Yeah, sir. Suppose the bandwidth is low or the latency is high. So how the device maintain secure and reliable connectivity?
Well, as I said, if even if there is low bandwidth, right, it already operates on a very lightweighted, data consumption. So if the bandwidth is low, what will happen is it will queue the messages, and it won't give incorrect result because the data packets are, unless the entire data packet is constructed, the system will not give you the response. So as I said, it works on complete message reception and acknowledgement. So once the entire message is constructed, earlier days when we used to have dial-up networks, right? We used to see that the streaming of the movies or something would happen on our browser itself. So these devices are built in such a way that even if the available bandwidth is lowest in case, they will construct the packet before giving you the response instead of giving any incorrect responses. So they would actually construct the entire packet, and once they have acknowledgement, then only they will respond to the end user.
Okay, thank you, sir.
Sure. You have something called as Docker. Docker is very fancy thing. You can create scalable testing environments using Docker. So what happens is, say, today I have a computer, Windows-based computer or a Linux-based computer, and I want to test a multi-node application, but I don't have the devices. How do I do that? Either I must have very deep pockets so that I can go to the market, buy multiple computers, come back home, and then start using them for my testing. But that is practically not possible. What Docker provides us is Docker provides us containerized environments for hosting multiple containers on a single operating system with minimal resources being used from your parent operating system. And then that simulates or emulates your multiple devices. And these devices are virtual devices. So they will give the simulation as if a real user is sitting in front of your application and is responding. So to emulate that multi-user, multi-device simulation or experience, Docker can be used. So that is one more thing which is very, very interesting. And I spoke about the BLE, which is the Bluetooth Low Energy and Zigbee, right? So yeah, I think I covered that. So yeah, that's how the entire simulation and testing things, they work together. So if I go to some more programming tools, then there are visual programming and integration tools for rapid prototyping. As we see, Node-RED is drag and drop interface. Somebody from Visual Basic world may be able to appreciate this, because in Visual Basic we used to drag and drop objects, and then we would write code in the background to control that dropped object. So this works exactly in the same manner. Blockly is a phenomenal tool. It is freely available. It's a collection of a lot of educational tools for beginners, and they can learn logic visually. So how Blockly works is it provides you entire flow of your whatever logic you are trying to build into your system, and it gives you a visual representation of the entire say for example, if I'm writing a logic gate in my system, then it will tell me that now it is time to now it is time to create something uh, you know this is where how my entire logic is flowing, and it will give me explain me the entire logic stuff in graphic sense. So yeah, I mean variables, loops, conditional things like custom blocks, and you can obviously even integrate Blockly with JavaScript or Python. So that's how, yeah, it is used. You can use it in DevOps pipelines, logic building for automation and whatnot. So if I go to some more examples of smart IoT devices which are popular in the market, Nest thermostat is something which learns your habits and adjusts the temperature automatically. So let's say a very healthy person goes to bed at 10 o'clock. By 12 o'clock, he is into his deep sleep, and he gets up in the morning at 4 o'clock. So between 12 to, let's say, 3 a.m., he is in a very deep sleep state. So at that time, this thermostat, what it does is it understands that this is where probably you don't need your AC to blast at full power. Probably when you are trying to sleep, that time you may want the room to be really cool and nice. But once you are asleep, then even if the AC maintains normal room temperature, you should be okay. When you want to wake up, it just cools down again sufficiently so that you don't get much into a comfortable zone, and which will give you a nice and warm environment. So it works in that way. It learns your habits and adjusts your room temperature accordingly, and that way it saves energy. Philips Hue lighting system, it allows you to control your home lighting scenes. You can have like mood-based lighting. When you're feeling very happy and whatnot, you can have very bright light. If you're feeling gloomy or something, you may have light according to the condition and whatnot. Ring doorbell is another very fancy product in the market. It would, stream live video, and it would even send alerts when somebody is at the door. They don't even have to press the bell. So if your favorite uncle or aunt is at the door, they would probably ring or give you a specific signal. If there is some annoying neighbor at the door and you don't want to open the door for them, it may give you a different signal and whatnot. So those are some applications. Wemo Smart Plug, again, very, very useful thing. This one particularly I am using personally. So it turns on and off the appliances, and it tracks the memory usage. So I have a computer at home which I usually keep online all the time. Okay, and what happens is that when I'm not using it, this plug understands that now it is time to make the computer to sleep, and it is exactly the same way in which you have battery saving devices built into your computer laptops. When it is plugged in or when it is plugged off, then what to do in that case? So this plug exactly works in the similar way and tracks your energy usage. Some more IoT devices. Fitbit and Apple Watch tracks your heart rate. Whoop is one more popular band which we see nowadays. all the athletes are going crazy for that. You can see a whoop band across the rest of every athlete. So what they do, they keep on tracking your body parameters and share it with your application running on your smartphone or whatnot, and it syncs with your health applications. Smart glucose monitors, I mean, patches are there, right? Now you don't have to worry about your insulin control or anything. You can simply stick the patch to your skin. It will automatically log how much blood sugar is there in your bloodstream, and it can accordingly inject the correct amount of medicine to your patient. Connected inhalers, I mean, patients with asthma or bronchitis, if their blood oxygen SpO2 saturation is low, it can automatically help them inhale and send oxygen into their bloodstream. So we are moving towards a really fascinating world, I must say. Connected vehicles, Tesla's connectivity suite, we all are very well aware about it. Controls climate inside the car, charging, navigation. I have not seen I have seen a Tesla in the US, but haven't seen one in Indore so far, but I'm sure uh, we'll see it very soon. Audi's Connect system offers remote diagnostic. So while you're driving the car, your data is sent to the Audi Connect system through your, a sat link, and that automatically keeps your driving behavior and whatnot. So, it is so interesting that, say, for example, I'm driving a car, and at some point in time, I start feeling sleepy. The car senses it, and it automatically sends the signal to my car system that either it wakes me up by sending a vibration in the steering wheel or on the seat or whatnot. ADAS or adaptive automated driving system is working on the same model as well. Water sensors we have in huge plants where they monitor the chemical levels, and then you have indoor pollution control systems and street lights, smart street lights, and whatnot. So all these things are already in place. And other fancy examples, dog collars, smart dog collars, or the one tap ordering and whatnot. So, as I said, I mean, we are becoming now lazy slaves to machines, actually. But what to do? That is how the world is now progressing. So, these are some other examples, bit outrageous, but yeah. So I'll quickly move to what is IoT cloud. Now, we all spoke about collecting a lot of data, but then what happens to this data? And cloud infrastructure is something which helps me to collect all that data and put into my IoT cloud, which allows me with my device management or my data ingestion and storage and analytics and insights and whatnot. So collection of data is done through my my sensor, right? But then once I collect the data, I have to process it, and I require powerful machines to process it. Cloud provides me easy, scalable infrastructure without actually buying something, but renting compute power, renting storage power, and whatnot, and performing all my operations uh, uh, in a flash and provide the results to me. So that is where IoT cloud comes into picture. And as I said, scalability, security, all these things. Scalability is without, breaking a sweat. It handles millions of devices. And if I have to scale up my system, I simply have to rent more infrastructure, and I can quickly scale up my system without even having to bother about a particular uh, buying a particular this thing, a particular server or something. So moving on. Popular IoT cloud platforms, we spoke about Amazon IoT, Azure IoT Hub, Google Cloud IoT. So I will not go into detail of each one of them because they are huge topics within themselves. But these are some popular cloud platforms which are available, because I want to cover important functions of cloud platform and then about security. So key functions of IoT cloud platform is device management, which happens through provisioning or authentication and monitoring the connected devices. Very important to monitor the connected devices, because as sir asked the question right some time back, that what if one of the function, one of the device malfunctions, what happens? So continuous monitoring is required. Continuous upgrades. Now, once you buy an Apple Watch or a Fitbit or a Whoop Loop, you don't go to store to push the latest firmware to it, right? It happens remotely. How that happens? It happens through your cloud platform. The application is transferred to your device, and it tells you that it will be upgraded exactly the same way your mobile phone operating systems are upgraded over the air. That's how it all happens. Grouping of devices, location tracking, and whatnot. These all are functions of device management within the IoT cloud platform. Data ingestion and storage, as I spoke about already. Collecting real-time data, storing that, then aggregating that data, handling high velocity data streams, and supporting structured and unstructured data format, both, right? I mean, you could have structured data format like your RDBMS and whatnot, but you can have unstructured data format like your text files are there, your CSV files are there, binaries are there. So this all type of data ingestion happens on IoT cloud. And my favorite topic, real-time analytics. So your machine learning and everything comes into this paradigm. You analyze the incoming data at real time, you find out the anomalies, and you react at real time. So my Apple Watch, if it senses that I'm going to have a cardiac arrest or something, it should send the signal immediately. Or otherwise, what is the point if I get a cardiac arrest right now and 2 hours down the line, my Apple Watch is sending the signal? By the time I would have been gone, right? So there is no point. So in real time, the entire processing has to be done. Alerts have to be triggered. So these all things happen on the cloud platform on my IoT cloud.
Sir, one question I have.
Sure.
Sir, what are device shadows in AWS IoT?
Can you repeat that?
So what are device shadows? I just heard the term device shadows somewhere. So in context with AWS IoT core.
Okay. Got it. So see, a device shadow is nothing but a blueprint of a device, which is a JSON document, and that document acts as a physical or rather a virtual representation of a physical device into the cloud. So for example, if I have a thermometer, right, then
Yeah.
a physical thermometer may look like a glass and some mercury inside it and some scales drawn over it, right? But to the system, it will look like a JSON file where there would be text messages, text parameters like state of the thermometer, temperature, reported temperature, and whatnot. So for human, we can see the device, but the machine cannot see the device. So for machine, we have to provide a way the machine would understand, and that is why we have the JSON template, which can be used for programming and which can be used as a structure for that particular device shadow. And essentially, how it works is that it updates your desired state, and then it syncs with your device. So the device reads the shadow, and then it updates its physical state. So if you're sending a signal in the shadow or in the JSON, the relevant action would be taken up on the device. So this is the concept of a device shadow.
Thank you so much, sir.
Sure, no problem. So, very important concept of security, because as we say that we are getting slaves at the hands of machine, but then security is one of the biggest challenge in IoT today. If you have weak authentication and outdated firmware, you can lose your entire bank account within a flash. But banks have to provide that security. Otherwise, why would the customer keep using their applications? So all these things, high security, high role-based access implementation, device authentication, secure APIs, all these things have to be provided by the applications, and that is not a simple task. And for implementing this, you have to have very secured protocols which must be put in place for ensuring that your system is up to the mark in terms of security. There are various vulnerability testing tools, penetration testing tools, which are there, which can assess the security of your system and tell you how secure your system is. Integrity and interoperability, right? Because see, you're using multiple type of devices during a day. Your watch is one device, your phone is one device. They are different type of devices, but then if they have to connect with each other, there has to be interoperability, and that is where you have to connect them with third-party applications like whatnot. Your mobile applications are there, your ERP suites are there, CRM suites are there. So these things, they come really highly into picture when you're talking about these different security options. Scalability and flexibility, again, very important function of cloud platform, IoT cloud platform. And it leads to huge security issues as well. Because if you scale your resources too quickly and your security infrastructure is not able to catch up, then what would happen? Your device may go in for a toss, right? And your application may go in for a toss, and millions of your users would be lying there without any proper connectivity. So to avoid that, scalability and flexibility has to be managed very meticulously with your application. Control panels, dashboards, mobile apps, control panel apps. Like, say, for example, we are talking about smart cities, but then there has to be a not a moral, there has to be rather a police sitting, which is looking at the control panel for real time traffic analysis. We cannot 100% depend on the machines, because, say, if I see a lot of traffic in a particular area, it may mean two things: that either there is a traffic jam or there is some emergency on the road because of which the entire traffic has stopped. So who knows, right? Either of these things could happen. So at some times you have to take human help as well to deal with the situation. And this is where, ma'am, your earlier questions reference would come into picture. Machines do think like humans, but they may not be able to make decisions like humans, because the one difference between human beings and the machines is the ability to experience emotion. And the way we experience emotion, that is how we can take a certain decision. uh, if we see a poor person on the road, we may want to help that person, but a machine is so analytical thing that if they see a poor person, they may probably choose to ignore that, or they may start thinking about why the person is poor, what may have happened to him or her, and whatnot. But if you see a hungry person, you will want to feed that person, right? But the machine may probably act in a different manner. So these are some things which set human beings apart from machines, and their thinking apart from human beings. So these are some of the security issues. And one very common example is if you keep simple usernames and simple passwords like admin1234, which is very obvious, you are making your system vulnerable to hackers. And you may have heard about algorithms like SHA-128, SHA-256, or a secure hash algorithm. So those algorithms are there in the market for securing your data. Outdated firmware, we obviously talked about that. If your firmware is outdated, you are not updating your system, you are making your system vulnerable to outside elements. Then you have something called as opaque device architectures, like for example, architectures of Apple system, right? They say that we don't share data with anyone. We keep the data with ourselves. So that is one very closed system architecture, which is complex, which cannot you cannot, if the rogues are using, or if the antisocial elements are using certain devices which don't allow you to look into those devices to read through the data or do your investigation, you are heading into a problem. So that is something which is an issue now. And insecure communication protocols. I mean, HTTP basic. If you send your request over HTTP, it is vulnerable for, it is susceptible to be for hacking. So always use HTTPS or HTTP over secured HTTP, and that can help you to secure your application. If there is poor identity and access management, then also your devices often give incorrect digital identities. Like your phone, if it has a face recognition system, but it is not properly built, then it can open to any face, right? So that has to be built into your system to make sure that
Sir, sorry to
your
interrupt
phone.
you. There was one question I missed in the chat box. May I raise?
Yeah, please go ahead.
Sir, how data acquisition, processing, and edge analytics can be handled in IoT devices?
Okay, sure. See, data acquisition happens through your edge systems, through your sensors. So data is collected from the sensor. It is then sent to your backend system where you have your algorithms, which are responsible for processing that collected data. And once that data is processed, it is again sent back via that edge system back to the device, and the entire loop completes. So this is how the edge analytics is handled in the IoT devices. Now, if you have a really lightweight system, you can build your analytics into the device itself, but it has to be really, really lightweight. Otherwise, it becomes really difficult to process the data at the device level itself. So this is how the entire loop completes.
Okay, thank you, sir.
So DDoS attacks, or the denial of distributed denial of service attacks, hijacking into botnets and whatnot, is something governments fight a lot against. So these are some things which are built into the systems to prevent such kind of attacks and whatnot. Botnets, they simulate multiple users, and they simulate the insertion of fake service request to your system, so that genuine services can be denied. So that also is physical tampering, and is a real threat to the system. So these are some of the major security issues which are faced by IoT systems not following the standard protocols, best practices, and whatnot in public areas. So that's why we say public Wi-Fi's, which are not controlled by passwords can be really risky. So don't share your personal data over public Wi-Fi and whatnot. So that's exactly what people mean when, because they are high risk, less secured, high risk candidates. So you may want to avoid that. So this was a bit about what I have studied about IoT and what I've worked with IoT over past few years as part of my professional career, and I hope I was able to provide some insights into it. But now I would definitely like to take your questions and try to answer them as per the best of my ability. So uh, I would welcome questions from you, please.
So one more question from my side. How the anomaly detection is implemented means like it is via machine learning based or rule based or cloud analytics, especially if we talk about IoT.
Anomaly detection, again, obviously it is rule based, definitely. There are pre-fed rules into the system, and there are different detection logics which are fed into your system. So what you do is you simulate your input data to the system, and the system would then try to calculate a few statistical parameters. Like, say for example, if I am giving a type of input to my system, human body temperature. Okay.
Okay.
So 101, 102, 103, these are some acceptable human body temperatures. I mean, real human body temperatures, which can be read by my thermometer. But the moment if the thermometer or the device says a reading of 10,000, then it is clearly an outlier, right? And that my system detects by the logic of self-learning that this is something which is falling beyond the acceptable limit, and it flags that as an anomaly. I've given a very simple example, but as your data set grows, you calculate different statistical measures. Like there is something called as a z-score, or there is something called as a chi test you apply and whatnot for anomaly detection. So that's one example. There are more such examples, statistical models like time series models, or what the time series is one I can think of right now, but there could be more, but yeah, time series is one which can tell us about anomaly detection in a system. So yeah, that's one example.
Thank you, sir.
Oh, I can see one more question by Jyoti ma'am, which says, please describe denial of service attack. Sure, I will definitely describe that. So, ma'am, let's say, for example, one fine day, you want to browse Google, and you try to log into Google, but Google says, I'm experiencing a very high traffic. I cannot answer your question. Very frustrating moment. I know it will not happen with Google, but just a very vague example. Essentially, what is happening is, what an attacker is doing is, an attacker is sending thousands of or millions of simulated requests to Google engine with notorious search request, and the system becomes so busy in serving those requests that at one point in time it just goes and fails to serve any new request. So this is deliberate denial of service to you, because I know you are trying to access the system, but I am hijacking all the resources of the system. So that is a denial of service, to deliberate denial of service to you. And when I say distributed, when I distribute this across multiple systems, it becomes a distributed denial of service. So that way I'm forcefully injecting false traffic into my system, so that other users are not able to access the system. So that is something called as a DDoS, or distributed denial of service, or deliberate denial of service. So I just saw the question in the chat box, so I thought of taking that.
Best example, I think, sir, this is to explain DOS.
Yeah, I have other examples as well. If I want to watch the match, but my kid is watching YouTube in ultra high definition, then I get low bandwidth. So then, in that case, probably I may be experiencing a glitch in my transmission, but he or she is enjoying YouTube in ultra high definition. So that could be one example. But since that cannot be controlled by people, I did not want to take that example, but that may also happen, And that is where sometimes, people say that if you make a video call and if the images are sketchy or the voice is choppy, people, what do they tell the first thing? Try to turn off your video and probably we may get a better bandwidth. So your video is eating up your bandwidth. And that is a kind of a denial of service to you as well. So that is one more example.
Sir, one request is there. Sir, will you? Is it possible for you, sir, to just to switch on your camera so that I could take one photograph of this meeting?
Sir, I will have to join through my mobile phone then because my laptop camera is not working.
Okay, no problem, sir, no problem. It's not compulsory. Just as a sake of memory.
No, I completely
No
got
problem,
that.
sir. No problem. No problem, sir.
Yeah.
Yes, sir. Ashri ma'am, you can continue.
Thank you, sir. Thank you for joining with us. It was really a profound and a very insightful session. And on behalf of CDGI, I once again express my heartfelt gratitude for joining with us. And thank you, sir. Thank you so
Thank you
much.
very much. Thank you very much for having me. And thank you, really. Thank you very much.
Siddharth sir, I just want to say something for you, sir. First thing, thank you so much, sir. Despite of such a difficult situation, you you have delivered the talk, and it was very difficult for any person to deliver the talk in such a difficult situation. So we are highly grateful to you, sir, for joining this session and delivered such a wonderful session, sir. And it was a wonderful session, and it's means sir, I enjoyed a lot the session. The session was means it was a wonderful session, sir. Thank you, sir.
Thank you very much for the kind words, and I
Thank
hope
you.
you all would be benefited by this some way or the other. Manoj sir, I can send you this presentation if you want.
Yes, sir. Yes, sir. You just send me the presentation because we need it, sir.
Okay, I'll send it.
Yeah.
I'll send it to your WhatsApp or your email.
Yeah. Thank you so much, sir.
Thank you very much.
Thank you so much, sir. Thank you, sir. Dear
Thank you.
participants, we can join back tomorrow at 6 p.m. for the day 4 of the FDP. Thank you, everyone, for joining and for the patience. Thank you, everyone. Thank you.